I'm Hyuk-jin Kwon. I'm the staff software engineer at Databricks, Apache Software Foundation member, and Apache Spark PMC member and committer. And I'm the top contributor in Apache Spark repo. All right, so today I'm going to talk about the no-code change in your Python UDF for arrow optimization. I made the title very interesting, exciting, so I'm happy that my talk is accepted. Hopefully the contents are exciting too. Before all, I'd like to celebrate myself because I hit the 2000 commit in the Apache Spark repo. There's a bit of a rough moments. Like there are some people who helped me a lot for the decade contribution. So I'd like to say thanks to them. All right, back to the topic, introduction. This session is actually designed for the beginners. So I just want to quickly check this guy. There's anyone who doesn't know PySpark, the Python UDF? Okay, okie dokie. Yeah, so this is the basically what I'm going to talk today. So I'm gonna go through the what's Python UDF. The Python UDF, you can run some of the random projects, right? So you can directly import the third-party libraries, and then you can use you can reuse the function that used to running in the single machine. You can use that function to the distributed machine. However, the performance itself is not very good. I'll discuss why it's slow, and then talk about it a little bit later. So we introduced the Arrow-optimized Python UDF. So it optimized the Apache Arrow. Do you guys know Apache Arrow? No? Yes. I'm gonna briefly go through that too. So you can turn it on and off. There's a new parameter introduced. So you can change your code, or you can set the one configuration. So out of your workflow, you can just switch the Spark configuration on. Then you can leverage the up to 2 times faster Python UDF without changing anything. Of course, I will talk about the benchmark wizard too. As I just mentioned, no need to change. And then lastly, I will talk a little bit about the Databricks stuff, because I'm the Databricks employee, and they pay me, so I will just talk a little bit about it at the last. All right, so Python UDF, just in case you guys are not very familiar with, seems like most of people know, so I'll quickly go through. So what's Python UDF? So Python is a user-defined function. So you can write your own logic in Python, and then you can run it in the PySpark. So for instance, on your right side, there's my upper, that's a user Python function, and then that's basically making your string uppercase, right? So this is actually very widely used. We analyzed the notebook usage in the Databricks before, and then 95% of users are using the Python UDF when they are using Python notebook. We actually investigated why it's so popular, because we have different many APIs, right? We have RDD API, mapping Pandas, and Pandas UDF. It basically enables directly your existing workload to be distributed, right? Suppose that you have a Python function that's running in local computation, and then you want to distribute the computation. You can just wrap it with the decorator, the UDF, then you can directly use that in the distributed environment. So it needs the minimized change. And then there are some libraries that are not supported in the PySpark, right? For instance, third-party libraries, the Python ecosystem, all the dependencies, you can directly use with the Python UDF. Plus, there are some logics that cannot be written easily in the PySpark expressions. I intentionally made up on your right. There's the Python UDF that basically just filter out the special characters and then just extract the username. This kind of expressions are, well, maybe you are able to do it with the Python expressions, but you're let's suppose that you're just Python user, you're very familiar with the Python logics, then it's pretty difficult to do it. So because of both reasons, the Python UDFs are very popular. As I mentioned, but the performance is not that great. There are several reasons behind, but basically you're serializing the row by row, one by one, and then you're using Pickle that is not designed for the efficient encoding. But as you guys might already know, we introduced the Pandas UDF, right? So basically, it's sending batch by batch. It's using Apache Arrow format. I will talk about it later. So it sends the batch by batch, and then when you execute them, then it can be executed with the vectorized operation that's leveraging the modern CPU design. I'll talk about it later. So why don't we use the Pandas UDF? Pandas is hard. It's difficult to learn, to be honest. It's a little bit embarrassing to say, but like my first time I started to learn Pandas, that's when I implemented the Pandas UDF. So that was like a few years ago. And at the time, what I learned that, firstly, the indexing and slicings are hard. I mean, I didn't even know, like Spark data frame doesn't have index. So I didn't know what's index. I mean, why is it there? I mean, why do you need it? And then slicing, and then you like add some like brackets, and then what's something weird inside, and then name. And then I didn't know what's even index at the time. And then the Pandas itself is that I'm a fan of Pandas, by the way. I need to introduce my features. So lots of implicit behaviors. Like for instance, here df.call, and then I did the comparison with the A, right? Now, I was expecting that there is singular value, like true or false. But suddenly, like it returns a series of bunch of multiple booleans. So this kind of things to the naive Python users, it's pretty difficult. Maybe if you're a data scientist, I mean, you might think that I'm dumb, but it was hard for me. And then there's no to the naive Python users, they're not really familiar with the vectorized operations. I was just I would say you want to change something in the list, I would do the for loop, but Pandas way, you have to do a vectorized way. That's why we introduced Arrow-optimized Python UDF. So you don't need to change your existing function, but you can leverage the arrow optimization under the hood by switching on and off configuration. All right, so bottlenecks. So I just mentioned that the regular Python UDF, it's great, it's widely used, but there are a bit of, it's not quite fast, right? The major reason is that we are doing one by one, 3D, the row by row, and then we are using Pickle. Pickle is not designed for the optimized transferring stuff. In fact, when you pickle, for instance, a string, then the size will even become bigger. So we are switching the pickle to the Apache Arrow under the hood. So I mean, since you guys know, I will just quickly go through. The Apache Arrow is the memory format, so it's optimized memory format, so you can put your data in the very efficient, small size. So you can read and write quickly, easily, and then it supports a lot of the different languages, for instance, R or Python, Java. So it's very efficient way to transfer data between process or even within process or within the shared memory. All right, so Pandas UDFs are already using the arrow, right? So when they send the batch to the Python worker, then they are already using the arrows. Then the idea is that why don't we just keep the existing transferring logic, but we just convert the arrow batch back to the rows, and then we just apply the function for individual rows. So that was the idea. Yeah, so this is the feature that I did. So we have two ways to enable this. So one is that we have a new parameter called use arrow. So you can specify that to true, then you can control the individual UDF to use the arrow or not. Or you can just leave your workload as is, and then you can enable the configuration called the spark.sql.execution.python UDF.arrow.enabled. Yeah. So you can specify the configuration in your Spark config file, or you can just fix your workload to the enable and then test it out. This is actually introduced from the Spark 3.5, but there has to be some optimization done. So this is actually still in progress. So I would expect this to be ready in Spark 4.1, and then we actually even want to enable this by default. So if you are interested, you can just try it out and see if it works. For DBR, the Databricks runtime is supported from 14.0. All right, so by using the arrow under the hood, actually there's another benefit. So the first one, the top one is that we are using arrow. The second one is disabled arrow. You guys might know that when the returned instance is different from the specified SQL type. For instance, here, the select, here the return type, I'm specifying the return type as string, right? But the data frame, it has a date. So when it happens, when arrow is enabled, it returns a relatively reasonable string representation of dates, right? But when you use the Python UDF, and when the types are different, then it shows something that weird strings. The reason behind is that we use the library that reads the pickled instance to the Java instance within the JVM. So here, the second, we read the pickled instance to the Gregorian calendar that instance, and then that's converted to the string. So my point is that when you use arrow, then you can get the more reasonable the representation of string types or other casted types. All right, so benchmark. Before I talk about the benchmark result in the Arrow-optimized Python UDF, no, this is not Arrow, this is Pandas UDF. This is a different one. So this is the Pandas UDF benchmark. So when we did that, it shows that the performance improvement up to 100 times faster. It's pretty high, right? So to be honest, I was expecting that such kind of performance improvement. But when we did the performance benchmark, then it shows up to the only 2 times. I mean, even fast, which is great, but we need to figure out why, right? So we investigated why. So the Pandas is like backed by the NumPy array, right? And then the NumPy array itself support the vectorized operation, so which is like CPU friendly, the SIMD, right? So basically, like NumPy allows your CPU to just bring the data batch and then just apply the computation in batch. But basically, the Pandas is like implemented under the hood by the NumPy. When you execute the function, then you can do the vectorized operation. But since in this Arrow-optimized Python UDF, we are changing the arrow batch to the individual row, right? And then we apply function for row by row. So you cannot really do the vectorized operation. So this one was like a little bit critical in the performance-wise. But still, since we switched the serialization format from the pickle to arrow, that boosted the performance up to 2 times. Oopsie. Yeah, and then, for the Databricks, a little bit, only one slide. We are trying to, do you guys know Photon? I don't know Photon, raise your hands. Okay, so Photon is basically like native engine. So basically the Spark engine is written by C. So like they are using like vectorized operation under the hood. So before that, we didn't support the Python UDF with Photon. But since we're switching from pickle to the arrow batch, right? So basically we can address the batch together and we can combine that to Photon. So we have the prototype now, and then it's working in progress. So the Python UDF will be Photonized, and then we are like exciting, and then we're benchmarking now. Okay, so key takeaways. So forget about everything I said. I mean, just this is summary. Yeah, so summary. So UDFs are widely used, but slow, right? Because people can run some custom logics, and then they can use the third-party libraries. They can use some like logics that cannot be written in the PySpark expressions. So we introduced the Arrow-optimized Python UDF that can be easily turned on and off. We added the 1 parameter at UDF, and then we added the 1 Spark configuration. And then we ran some benchmark. This is not fast as the Pandas UDF, but reasonably fast because it can be up to like 2 times faster. And then very good one benefit is that you don't have to change your code. So you just try the configuration on and see if it becomes faster or not. So it's pretty easy to try. Lastly, Databricks specific, we're trying to Photonize it. So if you're like Databricks customers, then you might be more happier. Okay. Yeah, that's what I prepared today. All right, thank you so much.